Okay, guys, so I already have solved this problem with two methods, but gonna make this video in English. So for the English, users, if you are watching, I don't know how many people are gonna watch, but let's try to do it again in English. And what I'm doing here is that I'm trying to solve the top interview questions because I'm also looking for a job right now, and all I have done is that difficulty. I've just sorted this in a difficulty order with easy. So I'm going to start first with easy problems and then we'll, try to move towards, medium and then hard problems as quick as possible. So the first problem here is the two sum. And what does this says is we're going to look like really quickly. And here is basically nothing. And if you look at the name itself, it's a two sum they're finding with, we're kind of doing summation with something like two. So I think we got the very idea. So here what we have is that we kind of have, arrays of integers and that's been named as nums. And we also have an integer that's called as target. So the very first intuition which I'm getting in this problem statement is that we're giving some, integers in a list, and we kind of have to use those integers to come up with a target to reach that target integer. And since it's a sum in already, so the sense which I'm getting is that we kind of have to use, I think, two sums means the two integers and add them together so that they kind of make equals to this target integer. Now, here what we have to do, which is very specific about this problem, is that we have to return the indices of the two numbers such that they add up to the target. That means we have to return the indexes where this list is, which I'm going to explain that how it is going to be, and of these two numbers which they add up to the target. Okay, and here the assumption that they are also telling us that we can make is that there is exactly one solution for each and every list. So whatever input they're gonna give, there is always gonna be one solution in that, and we may not use the same element twice. That what that means that we cannot use three with the same index at the same place at a twice. So that's a really important information for us. And see, with problem solving, always remember that try not to jump immediately. Just try to read the statement very specifically at first, because it's really important. Sometimes you miss out like really important details and you start solving a problem for a very different approach, and that's gonna end up in nothing. And like this is, I think, a really important statement again, that you can return the answer in any order. And by that, I think what they mean is, if you pay attention here, is that we have to return the indices of two numbers. That means the indexes are really important and of those numbers, and we cannot change. Means what I means by is that whatever integer is at place at that particular index, we have to return that index itself. We cannot change the position of the integer from that index. So that's important. That's really important. And we can return the answer in any order. I think by that mean is like, for example, if we look the example here, 2 7 11 15, the target was 9, and if you look that 2 and 7 kind of add up, and if you add these two integers, they kind of add resultant to the 9, and 0 and 1 is here. That means the 0th index and 1. And I think by this statement what they mean is that we can also return 1 and 0. We'll see later on when we try to run the example here, whatever we gonna code with these examples. We'll see that, oh, are they gonna be coming as the the right answers or not. So let's try to understand first that what here they mean. Oh, let me connect my right tab first because of the mouse. So whatever the example they have given is that 2 7 11 and 15. I think that's the example that we have. Yo, and if you pay a little, what happened? Where's my system? Why it's not showing? Wait, why is it not showing? What? Now how I'm gonna know where's my cursor is, bro? Sometimes this tag thing, like here it is showing the cursor, but here, oh god, this is gonna be really difficult for me. We try up here. No, man. How I'm gonna do now? Where's the wait, let me go with the white background. I hope that it will show. I don't know. Format background with yellow. No, white, not proper white, but like this much white. It's showing. Oh, something happened. Wait, let me disconnect and reconnect it. And I think it will show up. No, it's not showing. I don't know where my cursor is, bro. Okay, let's try to understand. So here's 0, 1, 2, and 3. So these indexes are there. I'm just, kind of, I don't know where my cursor is right now. So the indexes is 2, 7, 11, 15, and we have a, target value is 9. And if we look a little bit attention that first, what we have to do is to pick the very first number, and we can do is by starting from we can start from the, right from 15 itself, but we're gonna start with 2, and then we have to try to, add 2 together with these numbers with one by one. So the first thing is that here, and that's the very first loop, while loop, I'll tell you. And then here is 7, and if we try to add 2 plus 7, which we got as 9. But what if that we have an example target value as 18? Like, how about that case? So what we can do here is, we already have, went through 2. So if we, add kind of, yeah, so if we try to add, 2 and 11, that's gonna result in 13. And if we try to, add 15, it's gonna result in 17. That's the thing. We have to reach the 18. We haven't like reached it. So what we're gonna do is that 2 has already been done. Then we'll look at 7, and then the remaining integers are 11 and 15. And we try to do the same thing. So that's the very first thing is the loop. We kind of, traversing from at the every element from the left to right, and then we're gonna traversing every element afterwards from left to right. That's the approach we are taking. And here, if we look, what the, we'll see this. So this is gonna result in 18. And now we don't have to go further because like we already have our answer. So the answer is going to be 1 comma 2. So that's the very first approach for the loops thing. So one loop for the very first, traversing, and the second loop is for the another traversing. So that's important. Now let's try to build this situation that what we have seen. It's not like really good approach, but it's gonna work. It's gonna work. So first of all, we're gonna start with int I equals 0. Why? Because it's the zeroth index, and we are, kind of doing. And why I? You can use like any variable name, but here we are using I because it's kind of standard in programming, like programming as of like we're gonna use ijk as for loops. And for example, if you look at logic and proof in mathematics, that there we kind of use, pqrst kind of thing, variable names for the statements that we have. I have that, I actually have explained that in a video in logic and proof in data structure part. So if you're interested, you can watch it. No, it's not, it's going to be ijk. And like here we're gonna start with I plus 1. Why? Because we already have picked the very first element. Now we're gonna, traverse the very next element and onwards. So that's a really important part. So god, what I'm doing, say less than, so nums dot size, we can, use one variable to, put these all together at the one place, but kind of do it like this so won't hurt too much. So that's okay. And here for I and j, and now what we have to do is to check whether the sum is equals or not. So nums of I plus nums of j equal target. So if that happens, what we gonna do is we gonna return. And if you look, if you pay a little attention, the return type here is a vector int. So we gonna return. Oh man, I think that's the way. I already did this in for the my Hindi series, so I think that did work. So oh god, no, wait, return. Oh, the first element. I just started typing it. I'm so, I don't know. I think the pointer thing has, kind of, have distracted my attention. And I don't know why I'm not able to see the pointer. So for is here. If we've been able to return, and since it's a vector and there's a solution which is being there, ij, but we're gonna have to also make one return, else it will show some error. So we're gonna just put this. It's I think it's not gonna be used at all because we already have exactly one solution for each and every list. So let's see. It worked. And the very, if you pay attention to this statement right here, which says the return the answer in any order, and I think what they mean by this is that we can, like, please, man, please. What we can do here is, we kind of like somewhat like that. I think this will also work, and it actually worked for the Hindi video. And it will, because it says that in any order, but you cannot change the order of the number with that index. That's really important, because we're gonna build up another type of solution here. And what we're gonna do here is, I think I'm gonna use the if also, but let's get rid of it. Let's get this inner loop for now. Nice. So let's look at the another approach. Hmm. Gonna use the green pen. I don't know why my cursor is not so difficult to go with. Oh, my cursor is showing now. Finally, finally, it started showing. Where's the cursor? Yeah, I already got. So fine, I got my cursor back. Okay, so let's take another example with another method. So 2, 7, 11, and 15 was our example here. Okay, and what we did is that we first tried traversing from from one side. What if we try to traversing from the both side? It's kind of gonna save us some time. And if we start traversing from both side, and we try to sum these two, if didn't work out, maybe these two. If this didn't work out, this is too much, then we can go this two. I mean, we got 11 and 2 kind of thing. We can minus minus this and plus plus this kind of thing. We can increment this one pointer, and we can decrement this pointer. But here is a problem. Put two people, and if it's still the process is hasn't been been or organized according to the need of these two people, because for one person this approach was good, going through one left to right. But here two people are working and they are not sync. Kind of sync, you can think of this way. Sometimes you have to optimize a problem for the need of two people or three people rather than for one people. So here is a problem. You don't know whether to decrement or increment, because you have no idea about the elements, how they are stored, and they are organized in unsorted way. So what we can do here is that we kind of sort, although this example is sorted. We can take another example is 5 2 4 3 1. So this is kind of unsorted, and you see right one is here. You don't know that whether this is the smallest element, the biggest element, or the some mid element. You have no idea about this element, and you particularly also have no idea about this element. So when this sort of situation is there and two persons are working, that means the two pointers are working, the very approach in these sort of problems is that we kind of sort it out. 2 3 4 5. But here is a problem, because our problem statements already claim that we cannot change the index of a particular variable or particular integer. So if we pay attention, is the 0 1 2 3 4. That's our index of this. What is happening with my frying pan, man? Wait, where's the cursor? All right, so sorry, I don't know what's happening with this right now. Oh god, something's happening. Just leave it. So if we do this, and if we pay attention that according to this new one, our index is somewhat like that, which we don't want at all. We don't want this. We want to preserve this index, not this one. Because if you look, that one is at the fourth position, and we already have changes to we have changes to zeroth position, which is not okay. So when this sort of situation is here, and we have to sort it also, because then our approach is not gonna work, and we have to optimize, which is the very need of problem solving. So what we can do is we gonna save the state of the index itself along with the integer. And for that thing, we have something called in C++ called a pair. Okay, and it's somewhat like integer kind of thing. We gotta make this sort of pair. But whenever any operation you do on pair, since we are making pair, we kind of save the state. We cannot, we have to make sure that this is bind to this and this is bind to this. Every element is bind to their indexes, and they don't change. And with pair, the very first element gonna change. So we're gonna take an example of husband and wife, and the first element is, we can think of it as wife, as wife is always right, and hubby is gonna always follow the wife. So we can think of this anyway. So any operation that occur on this pair, which is this couple, this pair, this husband wife relationship, everything is done by wife, and husband is just to follow. Okay, so that's, I think, a very good approach to understand this pair thing. So whatever you're gonna do, so we have to kind of sorting is done for the wives. We're gonna sort according to wives, and husband is gonna follow them all together. So for this approach, let's try to build the intuition, which we have kind of have discussed. So here what we have to do is to create the pair at the very first time. So vector pair and integer. We're gonna name this as wife underscore hobby. Got it? And now we have to fill this vector pair with the index and the and the element itself. So we're gonna be like waifu underscore hobby. I think I'm gonna copy this because I'm gonna need this variable name quite a lot of time. Dot pushback. There is a method. There is this function back. I type back. I mean, come on, man. And since we are pushing it all together in pairs, and husband wife are always going to be pairs, so it's the nums of what was that, I? Yeah, it's I and I itself. Because see, we don't want to change the index, we don't want to change its position, we don't want to perform any operation on the index. We have to perform every operation on the elements, and we have to preserve the state of the index. That's what we are doing here. And since this is done, what we're gonna do is that we have to sort it out. And after sorting, what we're gonna do is this and the first, because waifu is always first. Wait, no, begin. It's begin. Wait, we were beginning. It's a sorting thing. I think first and second came in a later. Oh yeah, that comes when you're accessing the element, not here. So we beginning and waifu husband dot end, because we are ending up telling the sorting that where it start and where it end. That's the important thing. And after having this, we're gonna have to intuition. We're gonna now have to access this pair kind of vector thing together. So integer I equals 0, I less than nums dot length, because it's always, oh, wait, oh, we forgot. Wait. After sorting, we also have to, we have done our operation. Now we have to put husband and wife all together on the work. So for that, we need some kind of name of a pointer. And I'm gonna name this as left pointer, and integer right pointer equals to nums dot size -1. Why? Because it's a zero based indexing kind of thing. So nums dot size, we can use a one variable to put nums and size at one place, so it's gonna reduce the calls to that function, gonna improve a little bit of fractions of efficiency. If you like really concerned about that, you can do that. So I plus plus, and what we're gonna here do is we kind of run through these pointers, which will work from left and right, which is important. So let's think what I'm doing. Wait, oh no, we're not using one point. What I'm doing, man, this thing, I'm gonna hate this, man. The drawing pad just have left pointer. Why we What I'm doing here is that if you pay attention a little bit, that we have to make sure that the since like see the two people are working all together. Where's my pointer? I can't see. So since two people are working together, and we have to make sure that they don't overlap. What I mean by that, if a work is done already, if a work is already being done by this person, we don't want this person to do it again, since he or she has already done from here. Okay, got it. So we have to make sure that the work doesn't done again. And since our condition is that it's never gonna be equal, so we have to make sure they never reach the equal point, because we don't want to add both or same element twice together. So we have to make sure that they remain distant. So that's why a left pointer, which is the left person, is always gonna be the right person, so that they won't overlap. So that's a really important intuition here with pointers kind of thing. So right pointer here, and now we have to check whether the sum is equal or not. So that's gonna be like waifu hubby of f pointer. We're gonna start from left pointer, since we also started with from the left side in our last sort of method which we use. And first, because waifu is always first, and in pair is the first part where we are dealing with, not with the second is gonna be preserved at every cost. And here, and that's kind of the left pointer again, left pointer, right pointer. Left pointer. Hmm. No, it's right pointer because we're accessing the last element here and the first element of the pair. I don't know, man. I think you guys are confused now by watching me. It's like this dude is just so confused. Like, no, I'm just that pointer thing with my drawing tab kind of have disturbed a little bit, and just have removed my attention from here. Now left pointer dot. Now we have to return the indexes, which is second comma waifu hobby of right pointer. You can use left and right, it doesn't even matter. Second. Now here's another important part. Else if. Now there's a thing. You see why we sorted it? Not only for one reason, like why we actually sorted it. See, if we haven't had sorted, what's gonna happen is that how is it gonna help? Where's my pointer, man? Where are you, bro? Come here. Yeah, here. Okay, it's typing. I cannot see again. I don't know, man, what's going on with my pointer. Okay, if you pay a little attention, that if for example, if the summation of 1 plus 5 gave us 6, and we have to find 7 as our target element, what this tells is that this sum is less than 7. And we already have known that since it is sorted from small to big, 1 to 5, what we can do is we can jump to next pointer here. So we can tell the left person, the waifu, as you can jump here, and when we find 2 plus 5, which is equal to 7, and then we have reached our case. And another case might be that what if you're trying to find as maybe the maybe the 5 as output. Okay, and 1 plus 5 was equal to 6, which is greater than 5. So what we're gonna do, we're gonna reduce the right pointer. Since we already have a bigger value, we can reduce it, and when we reach 4, it's gonna result as in 5, which was the answer. So that's the thing, that's the intuition here. So what we're gonna do is left pointer plus plus in this one, and here with else, as simple as that, could be so right pointer minus minus, which is like, I think, would turn everything right here. And if we are right, and if I haven't missed anything after all these stupid mistakes which I made in this video, hopefully, where is it? Oh man, I'm so, what I'm doing. Is it fine? It's fine. Do it. Bingo. Got it? And then submit it. I think, oh, I haven't submitted the last solution. Oh god, okay. Wrong. What happened, man? Bro, wait. Where I missed? I think I missed something. First. Oh, okay. We. Marlene, just stay away. It worked. See? Okay, this time isn't that efficient, but like a little bit an hour ago, like I had like pretty good efficient code. I don't know what happened with this one. Is there anything changed? Push, I don't know. Is there anything that I don't know, man. I don't understand these compiler thing, and leave it. So that's for this video. Now we're gonna start the after two sum. We're gonna start the new problem, which is sort it out. Roman to integer. Got it. Okay. Bye.